Today we're going to learn about exponential properties and more particular about exponential equations pre-skills. This is the properties we're going to need to be able to solve exponential equations with no logs. So let's start with the negative powers. For example, if you have 3 to the power of negative 1, well, that's 1/3. If you have 4 to the power of negative 1, that's 1/4. If you have x to the power of negative 1, that's 1/x. And if you have y to the power of negative 1, that's 1/y. See, the negative 1 really represents a fraction, so this is not really 3, this is 1/3. The negative 1 is telling you that this base of 4 is actually 1/4, and likewise here. Okay, what happens if you have 5 to the power of negative 2? We still have to follow the concept of the negative, so this is still a fraction, but it's slightly different now because it's not 1/5 to the power of 2. So the negative is still indicates a fraction, you just have to make it power of 2 on the bottom. Now I know that 5 squared is 25, that's 5 times 5. Okay, so what it is 2 to the negative third. Well, the negative tells me it's a fraction, so it's 1/2 to the negative 3. Oh, I'm sorry, positive 3. And I know that 2 times 2 times 2 is 8. Okay, when you have a fraction, 1/5, and it's to the power of negative 1, what's going to happen is going to switch the fraction. So it's really 5/1. Okay, so if we have 7 to the power of negative 1, well, this is going to be 7/3, because the negative is really just switching the numbers. If you have 5/3 to the power of negative 2, well, we're going to flip the fraction first. We're going to leave the 2 there. So I flip the fraction, and then I'm going to apply the power. 3 to the power of 2 is 3 squared, which is 9. And 5 to the power of 2 is 25. If I have 5 to the negative 1/7, you do have to be careful right here. You do have to be careful here because the negative 1 doesn't really apply to the whole fraction, so I'm not going to be switching it. The negative 1 only applies to the 5 here. So in reality is 1/7 times 5, which is 1/35. The reason it didn't switch the fraction is because I don't have parentheses that will make my fraction switch. Sometimes you're going to need some skills. You need to be able to transform this fraction into a negative exponent form. Okay, so in this case, I know 1/3 is the same thing as 3 to the negative 1. Likewise, if I have 1/9, well, 9 is 3 times 3, which then this is 1/3 squared. But then I want it in negative form because this is in the bottom. This is really 3 to the negative 2. If you have 1/27, 27 is made out of 3 and 27 is made out of 3 and 9, and 9 is made out of 3 times 3. So my prime factors are 3, 3, and 3. So the equivalent of 127 is 3 to the third. But because this is a fraction and I want to express it as a negative exponent, this is equivalent to 3 to the power of negative 3. So if we have 5 to the power of 0, anything to the power of 0 is 1, guys. So 6 to the power of 0 is 1. 100 to the power of 0 is 1. X to the power of 0 is 1. Y to the power of 0 is 1. 1/3 to the power of 0 is 1. X times z squared to the power of 0 is 1. It doesn't matter what it is, anything to the power of 0 is 1. Okay, and a skill that you're gonna need is condensing. Now, condensing is the same thing as simplifying, but I like to call it condensing because we're gonna make multiple bases into one. So for example, we have 2 to the power of 5 times 2 to the power of 6. Because these two bases are multiplying, we're gonna add the exponent. So in this case is 11. So if I had 3 to the power of x times 3 to the power of 5, then this will be 3 to the power of x plus 5. Now, what happened here is we converted these two like bases into one like base by adding the exponents. What's going to happen here, because these two similar bases are dividing, we're going to subtract the exponents. So you're going to have y minus x. So we turn this two-base expression into a one-base expression. So in a way, we condensed it, we simplified it. Now, if we put it all together, so 2 to the power of 5 times 2 to the power of x over 2 to the power of y. We do have common base of 2. So we're going to write one base, and 5 is positive, x is in the top, so it's positive, and because y is the one in the bottom, we're going to put negative. And this is my condensed answer. Now, sometimes the condensing part is not going to be so obvious. They're going to give you 4 and 2, so obviously we don't have common base. But maybe if I just do prime factor 4, well, 4 is made out of 2 times 2. So if I rewrite 4 as a base of 2 will be 2 squared. Now they do have common bases. And last time I checked, this is y minus 2, because this is in the top, this is in the bottom, so that's positive and that's negative. What happens if you have 27? Okay, let's look at 27 over 3 to the x, 3 to the y. Well, 27, maybe we have common base there, so it's made of 3 times 9, and that is a prime. 9 can still be factored into 3 times 3, and that's a prime, and that's a prime. So 27 can be written as 3 to the power of 3 over 3 to the x, 3 to the y. Now we're going to condense it. They do have common bases. So the 3 is in the top, the x is in the bottom, so it's a minus, and the y is in the bottom. So that will be my condensing. Okay, so if you have this problem, I noticed that I do have this parentheses and the exponent, so I probably should distribute the exponent. So when you have powers to a powers, you multiply the powers. So in this case, this is a power, and this is a power, so that will be 2x. Power to a power, multiply the powers. So what's 2 times 2 is 4. And then we end up with 3 to the 5. And this will be 2x is positive, 4 is positive, 5 is negative. We do have like terms at the end. 4 and 5 are both numbers, so we end up with negative 1. And there you go. Okay, if you do have one like this and you do have a negative exponent, remember the negative exponents when you have a fraction like this, You're going to flip it first. And then you're going to condense. So in this case, it would be 4, 6 minus 3 minus x. 6 in the top, 3 is in the bottom, x is in the bottom. That's why the minus. And last time I checked, this is 3 minus x. There you go. So we are expressing our expression into one single base with a power. And that's where we're looking for the condensing point. Now, if you have a problem like this, where you have a -2, the first thing I'm going to do is I'm going to get rid of the negative. So what I'm going to do is I'm going to get rid of the negative by switching my fraction inside, because the negative power gives me that ability to switch it. Now I'm going to distribute the power. 5 is a power, 2 is a power. We're going to multiply the powers to 10. And 2, the power is x, the power is 2, so it's going to be 2x. And this will be, as one single base, it will be 10 minus 2x. So if you have a problem like this, I do not have common bases, so I should probably convert the 8. 8 is made out of 2 times 4. 2 is the prime, 4 is 2 times 2. So the equivalent of 8 is 2 to the third. So we do have common bases. We just have to convert it. Now we do have to get rid of this negative first. So I'm going to switch the fraction inside. So it's 2 to the third over 2 to the x. We still have the power of 2. And this is a power, this is a power. We're going to multiply those numbers. So that's 6. This is a power, and this is a power. So we're going to say 2x. So if I want it to be 2 to the power of 6 minus 2x.